Portfolio expected return and variance. Portfolio expected return is the weighted average expected return of a portfolio with n securities. Let's say we have a very simple portfolio which consists of two stocks, stock 1 and stock 2. Let's say that stock 1 represents 80% of your portfolio and stock 2 represents 20%. If the expected return on stock 1 is 10% and the expected return on stock 2 is 16%, then what is the expected return on this overall portfolio? The answer is that the expected return is the weighted average of these two returns. And that makes sense because clearly if the first stock represents 80% of your portfolio, then the overall portfolio return will depend a lot more on stock 1 relative to stock 2. So if we take the weighted average of 10% and 16% weighted based on how much you have in the portfolio, you will do 10% into 0.8, which is coming from the 80%, plus 16% into 0.2. You do the maths and you will get, so that is the portfolio expected return. To put this in general terms, we can use the formula shown here. The expected return on a portfolio is the weight of your first stock times the expected return on the first stock plus the weight of the second stock times the expected return on the second stock, and so on. You might also be concerned about the variance of the returns, and computing the variance is a little more complicated. We can't simply say that the variance of this is 25, the variance of this is 30, and we take the weighted average of the two. That does not work because these two stocks might move up and down together. It is also possible that when this stock goes up, this stock goes down. It is also possible that the movement of these two stocks does not depend on each other. So before we get into the formula and the discussion related to the variance of a portfolio, we need to understand the relationship between the returns on stock 1 and stock 2. Mathematically and statistically, those returns are expressed through measures called covariance and correlation. So let us understand these two concepts first before we discuss the variance and standard deviation of the portfolio. Covariance. Covariance is a measure of how two variables move together, and this is the somewhat complicated looking formula for computing the covariance between the expected return on stock I and the expected return on stock J. I will just say this briefly but then illustrate through an example. So the covariance between I and J is the expected value of this product. The first item here is the return of stock I under a given scenario minus the expected return of I, and then we multiply it by the return on J minus the expected return on J. We do this for different scenarios and then come up with the probability weighted average of the different products. Now that might have been hard to understand, but let us go through an example. Say we have two stocks A and B, and we are given the returns of the two stocks under different scenarios. There is a 15% chance or a 0.15 probability that we will have a good economy, and in that scenario the expected return on A is 20%, the expected return on B is 40%. There is a 60% chance or 0.6 probability that we will have an average economy, and in that scenario the expected return on A is 15%, the expected return on B is 20%, and finally there is a 25% chance or 0.25 probability that we will have a weak economy, and in that situation the expected return on B is 0 and the expected return on A is 4%. We now need to compute the covariance, and remember, covariance is a measure of how these two stocks move together. Just simplistically, if the two stocks go up together and then they go down together, that means they have a positive covariance. If they move in opposite directions, then we say that they have a negative covariance. Simply looking at these numbers, when the economy is good, both stocks do relatively well, and as the economy weakens, the performance is not as good. So just at a high level, it seems like the covariance is going to be positive. Let us now look at calculating the actual covariance number. To do that, the first step is to compute the expected value for the return on A, that is this item. So imagine that I is stock A and J is stock B. So we need to compute the expected return on A and the expected return on B. As you've seen before, the expected return on A will be 0.15 into 20 plus 0.6 into 15 plus 0.25 into 4, and that is 13%. The expected return on B is 0.15 into 40 plus 0.6 into 20 plus 0.25 into 0, and that is 18. Then to compute the covariance, we have to come up with the expected value of this product, and the way we do that is look at the first scenario, which has a 15% probability, and then this product here is the return on A minus the expected return on A in the first scenario where the probability is 15%. In the first scenario, the return on A is 20% or 0.2. So we have 0.2 minus the expected value of A, which is 13% or 0.13. We multiply that with 0.4 minus 0.18. Notice that in this scenario, the first scenario with a probability of 0.15, the return on B is 40% or 0.4 minus the expected value for B, which is 18 or 0.18. And then you move to the second scenario, probability is 0.6, and then we have 0.15 minus the expected value. For B, we have 20% here minus 0.18, which is the expected value. And then in the third scenario, 0.25 probability, 0.04 is the expected return on A minus 0.04 is the return on A in this scenario minus the expected value of 0.13, and then 0 minus 0.18 from here. When you do this calculation, you come up with 0.0066. This is a positive number as we expected, which means that A and B move up and down together. So to summarize what we've talked about, covariance is a measure of how two variables move together. The value will range from minus infinity to positive infinity. We'll have positive numbers if the variables move up together and then down together. The covariance will be negative if the two variables tend to move in opposite directions. The main issue with this measure is that it is difficult to interpret. So on the previous slide, where we came up with a number of 0.0066, it is hard to say whether the covariance is strongly positive or not. To address that problem, we use another measure called correlation, which is a standardized measure of the linear relationship between two variables, and the values or correlation will vary between -1 and +1. A correlation of +1 means that there is perfect positive correlation, where a correlation of 0 means that whether this stock is going up or not has no bearing on what the other stock is doing. So connecting back with material that we saw in probability, a correlation of 0 would mean that the two events, stock A going up and stock B going up, are independent. The formula for calculating correlation, and this symbol is the symbol for correlation. So correlation is equal to the covariance between the returns on the two stocks divided by the standard deviation of the return on the first stock multiplied by the standard deviation of the return on the second stock. So you need to remember this formula. If you are given the covariance and the two standard deviations, you can compute the correlation. From this formula, you can also see that covariance between the returns on two stocks is equal to the correlation times the standard deviation of the first stock times the standard deviation of the second stock. So this formula is important to memorize. It allows you to move between covariance and correlation. Just to understand how to calculate correlation, let us take the same data which we saw a couple of slides ago and let's compute the correlation. You have already calculated the covariance, and let us say that you now also calculate the standard deviation of A and standard deviation of B. In the previous lecture on this reading, we talked about how to calculate the standard deviation of variables such as this. You can use the calculator method or you can use the longer formula, but essentially when you compute the standard deviation of these returns given the three different probabilities, you should get 5.48% or 0.0548. The standard deviation of B is 0.1229. Given these numbers, you simply plug into the formula and you come up with a correlation of 0.98. Notice that this correlation of 0.98 is very close to 1, and this tells us that the correlation between the two stocks is very strongly positive. So it is almost 1, and this number is much more meaningful than 0.0066. 0.0066 is simply telling us that the correlation is positive. It is not telling us how positive or how closely the two variables move together. But a 0.98 number tells us that the correlation is very strong. And simply looking at the data over here gives you a sense. Now it is your turn to solve a practice question. You have two companies, Lemon and Demon, and they have the following probability distribution in different situations. You need to compute the covariance of the expected returns. Here is what you are supposed to do. First, compute the expected return of L, then the expected return of D, and then using the formula or the method that we talked about, you come up with the covariance. Next, for the same data, you need to calculate the correlation. And here, all you do is come up with the covariance, which you did on the previous slide. You have to then compute the standard deviations for both stocks. Correlation divided by the product of the standard deviations should give you 0.99. So this is saying that the two stocks are very strongly correlated. Now we are in a position to talk about both expected return and variance for a portfolio. Let's say that I have a portfolio that consists of two stocks, Oracle and Mindtree. Oracle represents 60% of the portfolio, Mindtree the remaining 40%. Oracle has an expected return of 12% and a standard deviation of 16%. We also have the expected return and standard deviation for Mindtree. We are told that the covariance between the returns on the two stocks is 0.0269. So what is the expected return for the portfolio and what is the variance? In this simple portfolio, I just have two stocks, Oracle and Mindtree. This is 60%. This is 40% of my portfolio. So the expected return on the portfolio will be the weight of the first stock, which is Oracle, so that's 0.6, multiplied by the expected return on Oracle, which is 12%, so into 0.12, plus the weight on the second stock, which is 0.4, multiplied by the return that is expected on the second stock, which is 16% or 0.16. So we do the maths and we get 13.6%. Next, let's compute the variance of the portfolio. So given this overall portfolio of two stocks, what is the variance of the returns on the overall portfolio? And here is a formula that you simply need to remember. It will be useful here, and it will be much more useful when you study portfolio management later. The variance of the portfolio is given by the weight of the first stock squared. So in our example, the weight of the first stock is 0.6. You need to square that, multiplied by the variance of the first stock. You are given the standard deviation of 0.16. You need to actually take the variance. So you do times 0.16 squared plus the weight of the second stock squared. The second stock is Mindtree. The weight is 0.4. So we have 0.4 squared. And then the variance of the second stock, which is 0.24 squared, plus 2 times the weight of the first stock times the weight of the second stock. So 2 times 0.6 into 0.4 multiplied by the covariance between the returns on the two stocks, that is 0.0269. You do the calculation and should get 0.0313. This is the variance of the overall expected returns of the portfolio. If you want to compute the standard deviation, all you do is take the square root of that number, and that will give you 0.177, which is 17.7%. Topics in probability. In this segment, we'll talk about Bayes formula and principles of counting. Bayes formula. Bayes formula allows us to adjust our viewpoint when we receive new information. Before I explain this formula, I will give you an example. Let's say that you are following a given company and you are particularly interested in the earnings per share announcement that this company will make after 2 days. So at the end of 2 days, the company will make an announcement about the earnings per share related to the last quarter, and the company is also going to make an announcement at the end of the day related to whether or not it will expand its operations. Let us say that the event that concerns you, or the event that you are interested in, is the event where earnings per share exceed expectations. Analysts have a certain expectation related to the earnings per share. Let's say analysts expect earnings per share of $2 per share, and you are thinking that the probability that earnings per share will exceed expectations is 0.5. This is our event. Earnings per share exceeding expectation is what we are calling our event, denoted by E in the formula. And the probability of this particular event, i.e. earnings per share exceeding expectation, let's say equals 0.5. At the end of the day, you will get new information about whether or not the company is expanding, and this information is denoted by the symbol I in this formula. As we have already said, the probability of the event being earnings per share exceeding expectation, is equal to 0.5 in our example. The question is, once you get new information about whether or not the company will expand, should you update your probability of this event? And the answer clearly is yes. If the company announces that it is expanding, then that is a good sign, and chances are that the company has indeed exceeded expectations, or earnings per share have or will exceed expectations. Notice that the earnings per share number is known to management earlier. What is only happening here is the announcement. You as an analyst don't know what the earnings per share will be, but you are using information such as company announcements to come up with a probability of whether the earnings per share will exceed expectation or not. So in simple terms, here is what Bayes' formula is doing. It is starting with a certain original probability of the event that you are interested in, and then that probability is being updated based on the new information that you receive. And the way the formula works is this: the probability of the event given the new information is equal to the original probability of the event times probability of information given event divided by the probability of the information. Many students have trouble over here with the conditional probabilities, but once we work through the numbers here, it will become easier, and then you have to find problems on Bayes' formula and practice them to really understand this concept well. So as we said, the original probability of the event being earnings per share exceeding expectation, equals 0.5. While we are at it, let us also see the probabilities of the other possible events. The probability that earnings per share meet expectation is 0.3, and probability that earnings per share are below expectation is 0.2. These are prior probabilities prior to receiving any new information. Also notice that these three probabilities are mutually exclusive and exhaustive. Let us also look at some conditional probabilities. The probability that the company expands given that EPS exceed expectations is 0.75. The way you can think of this is as follows. The company management, which is ultimately announcing the EPS over here, already knows the EPS number. This EPS number has not been announced, but you as an intelligent analyst know that the company is more likely to expand if the EPS number is good. So you come up with these conditional probabilities, and these are subjective probabilities where you estimate that the probability that the company will give this information or company will expand given that EPS exceed expectation is 0.75. The probability that the company expands given that EPS equals analyst expectations or EPS meets expectations is 0.2. And the probability that company expands given that EPS are below expectations is 0.05. It should be fairly logical that this number is small, because clearly if the EPS is low or weak, then probability that the company will be expanding is low. So these are your conditional probabilities. Now let's say you get to the end of the day and the company makes an announcement. The new information or the announcement is that the company will indeed expand. Here is where we use Bayes' formula, because now with the new information we need to update this probability. So given that new information, we now say that the probability of the event being earnings per share exceeding expectation, given the new information is what? So we need the original probability of the event, which we have 0.5. We need the probability of the information given the event, which we have over here. Remember, the information is that the company expands, and we had this number over here. The probability that the company expands given that EPS exceed expectations, that is the event E, is equal to 0.75. So we know this number is 0.5. We know this number is 0.75. The question is, what is the probability of the information? And notice, this is a unconditional probability. To compute the unconditional probability, given several conditional probabilities, we need the total probability rule. So let us use it. The probability of the information, which is the first thing we need to find over here, is equal to the following. It is the probability of information given the event being EPS exceeds expectations, times the probability that EPS will exceed expectations, plus the probability of the information, i.e. company expands, given that EPS meet expectations, times the probability that the company will meet expectations. So we'll express that event as M, and then plus the probability of I given B, where B is a situation where EPS is below expectation, times the probability that EPS is below expectation. We have all these probabilities. Probability of I given E is 0.75. Probability of E is 0.5. Probability of I given M is 0.2, and the probability of M is 0.3. The probability of I given B is 0.05 times probability of B is 0.2. You add up all these numbers and what you should get is 0.445. So the probability of I being the information, so information, the probability that company expands is 0.445. So this is the unconditional probability that the company expands, and this is the probability that you are actually computing before the information was released. 0.445, that is what you plug over here. So instead of pi, you can now put in 0.445, and when you do the maths, 0.5 into 0.75 divided by 0.445, what you should get is 0.84. So the interpretation is that the probability of the event being earnings per share exceeding expectation, given the new information that the company expands, is 0.84. And this makes sense. Our original probability was 0.5. This has gone up to 0.84, which makes sense because when you have this new information that the company expands, then obviously there is a greater chance that EPS will exceed expectations. Now we will talk about principles of counting, which are much simpler than Bayes' formula, and we will essentially talk about the multiplication rule, the factorial, labeling, combinations, and permutations. Let's first talk about the multiplication rule. Let's say that you have a process that consists of 3 different tasks. Task 1, task 2, and task 3. Let us say that the first task can be done in 4 different ways. And then once you've done the first task, the second task can be done in 2 ways. And once you've done the second task, the third task can also be done in 2 different ways. So the question is, what are the total number of ways in which these 3 tasks can be done? And the answer is arrived at using the multiplication rule. So the number of ways in which the k tasks, k is equal to 3 in this simplistic example. So the number of ways in which 3 tasks can be done is equal to the number of ways in which the first task can be done, which is 4, times the number of ways in which the second task can be done, given that the first task is already done, that is 2, and the number of ways in which the third task can be done, given that the second task is done, that is 2 over here. So the answer to this question, the number of ways in which these 3 tasks can be done, is 4 times 2 times 2, that's 8 into 2, which is 16. A common application of the multiplication rule is the factorial, and you will see this very often. When we say n factorial, what we mean is the following: n into n minus 1 into n minus 2. And let us take a simple situation to understand the use of this formula. Let's say that you are in charge of a research department, and this research department is evaluating 4 different industries. And you also have 4 research analysts working for you. You need to assign these 4 research analysts to one industry each. In how many ways can you assign the first research analyst? The answer is you can assign him to one of 4 industries, so you can assign him in 4 possible ways. Once the first analyst is assigned, the second analyst can be assigned to one of 3 possible industries. So you can do that 3 different ways. Then we can assign the next analyst in 2 different ways, and then the final analyst will be assigned to the one remaining industry. So notice that with 4 different analysts, the total ways in which they can be assigned to industries is 4 times 3 times 2 times 1. This is also called 4 factorial for short. So 4 factorial is equal to 4 into 3 into 2 into 1. And what you see here is the general case scenario where we say that n factorial is equal to n into n minus 1 into n minus 2 and so on until we come down to 1. And just to hammer this in, 4 factorial would be 4 into 3, which is 12. 12 times 2 is 24. Once you've understood the concept, you can simply use the factorial button on the calculator, which is right here. So to calculate 4 factorial on your calculator, you simply type in 4 second and then this factorial over here. Next we talk about labeling. Say you have n items of which each can receive one of k labels. The number of items that receive label 1 is n1. The number that receive label 2 is n2 and so on. To understand this, let us look at a simple example and then we'll see how to use this formula related to the number of ways in which labels can be assigned. A portfolio consists of 8 stocks, which means that n is equal to 8. So you have n items, here we have n stocks, so n is 8. The goal is to designate 4 of the stocks as long-term holds, designate 3 as short-term holds, and designate 1 stock as a sell. Now notice each of these is a label. So long-term holds is a label, short-term holds is a label, sell is a label. So k is equal to 3 because k is the number of labels. The question is, in how many ways can these labels be assigned to the 8 stocks? And that is where this formula comes in. The number of ways in which the labels can be assigned is equal to n factorial. So in our example, that would be 8 factorial because n is 8 over here, divided by n1 factorial. This means that for our very first label, which is long-term holds, the number that need to be in this or under this label is 4. So n1 is equal to 4, and that is this item over here. So divided by 4 factorial multiplied by n2 factorial. The second label is short-term holds, and we need to designate 3 stocks under this label. That is the n2 factorial. So we say multiplied by 3 factorial. And then the third label is sell. Only 1 stock needs to be under this label, so we multiply by 1 factorial. Now if you solve this on the calculator, you can simply type in 8 factorial divided by 4 factorial times 3 factorial. 1 factorial is simply going to be 1. If you do this, what you should get is 280. So that is the number of ways in which you can assign labels to 8 stocks. Permutations. Permutations refers to the number of ways to choose R objects from a total of n objects, where the order in which the R objects are chosen does matter. Here is the formula for NPR. N factorial, that's the total number of objects, divided by n minus r factorial. Let's look at a simple example. Say you have a portfolio of 8 stocks, so n is equal to 8. We decide to sell 3 stocks. How many ways can we choose 3 of the 8 stocks to sell if the order of the sale does matter? This means that we use the permutations formula. R is equal to 3. So the formula is n factorial, which is 8 factorial divided by 8 minus 3 factorial. So that is 8 factorial over 5 factorial. You can do this on the calculator and you should get 336. Notice that the calculator has a NPR function. To use this directly, you can simply type in 8 and then second, then NPR, and then 5, and that should give you the same answer. Next, let's talk about combinations. The number of ways to choose R objects from a total of n objects when the order in which R objects are chosen does not matter. And here is the formula for NCR. Again, let's look at an example. A portfolio manager wants to eliminate 4 stocks from a portfolio that consists of 6 stocks. So n is equal to 6 and R is equal to 4. How many ways can the 4 stocks be sold when the order of the sale is not important? So the order is not important. That means we need to use the combinations formula. If you plug in over here, you have n factorial, which is 6 factorial, divided by n minus r, that is 6 minus 4 factorial, multiplied by r factorial. R is equal to 4, so multiplied by 4 factorial. When you do the maths, you get 15. And again, notice that you can do NCR directly on the calculator. So just type in 6, second, NCR 4, and that should also give you 15. So that is it in terms of this particular reading. I will quickly summarize the most important points. We started by talking about probability. You need to understand the concept of mutually exclusive and exhaustive events. You need to understand the concept of conditional probability, where we essentially talk about a probability conditional on another event. We then talked about the multiplication rule. So the probability of A and B, the joint probability, is equal to probability of A conditional on B times the probability of B. We also need to understand the addition rule, which is probability of A or B, which is probability of A happening or B happening or both happening, is equal to probability of A plus probability of B minus probability of AB. So that is the joint probability of A and B. You also need to understand the total probability rule, which essentially is a way of moving from a conditional probability into a unconditional probability. So the unconditional probability of A is equal to the probability of A given a particular scenario times the probability of that scenario plus the probability of A given not that scenario times the probability of not that scenario. Not that scenario is often denoted as S complement. This is a simplified 2-scenario version of the total probability rule. This particular rule can be expanded into multiple scenarios as long as all the scenarios are mutually exclusive and exhaustive. We then talked about the expected value of a given random variable, which is fairly straightforward. We simply take the different values of the random variable and multiply by the probabilities for each of those random variables. So if a random variable can simply take on two values, x1 and x2, then the expected value would be the probability of x1 times x1 plus the probability of x2 times x2. Variance then gives us a sense for how spread out the random variable might be relative to the expected value. That formula is a little bit complicated, so if you need to revise it, you can go back to the notes, plus you need to know how to calculate variance using the calculator. Covariance is a measure of how two variables move together. Covariance being positive means that variables generally move up and down together. Covariance negative means that if one variable is going up, the other is likely to be going down. Then we talked about expected value and variance of a portfolio. The expected value was fairly straightforward. Variance of a portfolio involves knowing the covariance between the different elements of the portfolio, the weightage of each element, the standard deviation of returns, and so on. And then finally we talked about counting, which involved permutations, combinations, and labeling. This is fairly straightforward. So that is it. What you need to do now is review the learning objectives, do the examples and practice problems from the curriculum, but recognize that the questions are fairly difficult. So if you have trouble, don't worry too much. Just try to understand the solutions. It is extremely important that you practice as many questions as possible from other sources. So Schwezer has a lot of good questions, plus you might get questions from FinQuiz and so on. You can also solve the questions that have been released by IFT. When you do a lot of questions, then you will be comfortable with this topic.